Hello, this is section 1.3 for Calc survey, and today we're going to continue our discussion with rate of change. So if y is a function of t, so y equals f of t, then the average rate of change of y between t equals a and t equals b is the change in y over the change in time, or as you can see, y2 minus y1 over x2 minus x1. It's just the slope formula. Now, the units of rate of change or average rate of change of a function are y, so the change in y, your y per unit of t. Okay, so dollars per unit or miles per hour, depending on what you're talking about. Okay, so nothing new, nothing new. Average rate of change of a linear function is the slope, and we talked about in the last section, this book's not going to call it slope, so you need to get used to this rate of change, average rate of change. Okay, and it's the slope, and the function is linear if the slope is constant, so if it has that common difference that we talked about in the last section. All right, so if a function is increasing, the values of f of x increase as x increases, which you can see over here. As x increases, your y values increase. Decreasing when your y values decrease as your x values increase. And then think this, what this is referring to is think of somebody walking from left to right. If that person is walking uphill, you know your function's increasing. If the person's walking downhill, the function's decreasing. Okay, and then concavity. So the graph is concave up if it bends upward, concave down if it bends downward. A line is neither concave up nor concave down. So, and where you change concavity is called an inflection point. So concavity, it can get a little tricky determining if it's concave up or concave down. Maybe think in terms of water. Would your water spill out, or would it be able to hold the water, if that helps you? Some students do have issues seeing concavity. So if you're one of those students, please let me know and I can try to help you. Okay. And then velocity is your average velocity. You'll notice it's very similar. It is slope, average, the change in distance over the change in time. So average rate of change of distance with respect to time. Yeah. So the distinction between velocity and speed, velocity will show direction with a positive or a negative. Speed is just a magnitude of velocity. That is not something you need to worry about in this class. Okay, but it's good to keep that in mind. And then lastly, in general, with a quantity P changes from P initial to P sub 1, we define relative change. And you'll notice you subtract the two values and divide by the original. So that might look familiar. You called it percent change in all your previous math courses. So you just subtract and divide by the original. Now, if the value goes down, it'll be a negative percent. You'll say it, or say it decreases. And then, of course, if it goes up, it's a positive percent change, right? So those are the big concepts. Nothing really new. Still doing slope, increasing, decreasing, concavity. Velocity is average rate of change. So, and I guess this is only the thing that change in the name, relative change, is percent change. So, okay, let's do some examples. So, information from a table. Here's our table. And that's all the data you have to work with. Don't assume anything. Don't try to make up data in between. Don't make assumptions about what happens. From 5 to 8, lots of things could happen. So you just work with what you know. So find the average rate of change from x equals 8 to 11. Okay, so average rate of change, that's just slope. So use the data, 4 minus 6 over 11 minus 8, and there it is. Is this function increasing or decreasing? Well, look at your values. You go from 12 to 6 to 4 to 0 to negative 3. It looks to me like it's decreasing. Is the graph of this function concave up or concave down? So you have a couple options. The best thing to do with this section is probably to plot the data, and it looks like that's what I started to do. But you could also look to see how drastically is it dropping. So from 12 to 6, that's a change in 6. And then you go from 6 to 4, which is a change in 2. 4 to 0 is a change of 4. 0 to negative 3. It's, I mean, with that really big drop at the beginning, you had a small change here, but then a bigger change. So sometimes you can really tell because there might be big change and then it dwindles off towards the end, so it'd be a concave up. Whereas if it was a smaller change at the beginning and then drops off, that could be a concave down. So sometimes you can tell. This kind of screwed it up a little bit. So you can plot the data, but my best guess would probably be that it's concave up. So try to plot the data. We'll mathematically figure this out in the future, so I'm not too worried. Okay, so here's another one, information from a graph. What intervals is the graph increasing? So when is, go from left to right, when is your function going up? So in this case, it looks like negative infinity until you get to negative 2. Then we actually decrease from negative 2 to 5. And then we increase again from 5 to infinity. So that's this. On what intervals is the graph concave up? So when would it hold water? When is it going to be concave up? So kind of estimate, I mean, if you said at 2 you think it changes concavity, I think that actually looks even better. That would be fine as long as it's within this region. We don't know how to calculate that yet, so we're going to work on that later in the year. So at 2, around 2 or 1, it changes concavity. So it's definitely concave down at the beginning. So that's here. And then we're concave up from 1 to infinity or 2 to infinity. Okay, I'd accept both of those answers. All right, then use the graph to the left to find the average rate of change between x equals 4 and x equals 7. So average rate of change is the slope of those 2 points. So you need 2 ordered pairs to find the slope. So get that from your graph. So 4, 3 and 7, negative 6. Find the slope, and there it is. And I went ahead and graphed it. It creates that secant line that we found the slope of. Okay, example 3. So information from an equation. So as you can see, we've done table, graphs. Now we're doing equations. We're hitting all the bases here. So find the average rate of change given the function between x equals 3 and 7. So plug those numbers in to get your ordered pairs, and then just simply find the slope of those 2 ordered pairs. Okay? And then it has us graph the function, which we did, 2x squared. That's here, that's this big parabola. And represent the average rate of change as the slope of the line. So I plotted these 2 points and then connected them with this line, and that's that secant line that goes through those 2 points. Had it hit the graph at one point, we would call that a tangent line. Just a little review there. But that 20, that's the slope of that secant line. All right, and then it says, which is greater, the average rate of change between x equals 3 and 5? So 3 and 5 would be here, roughly. So imagine that secant line compared to 7 and 9. So 7 would be up here, and then 9. So, oh man, that 7 to 9, that's going to be way steeper. And I actually calculated it, but you can visually see that the 7 to 9 is going to be your steeper slope. Okay, and then the last concept, that relative change. So remember, you subtract the 2 values and divide by the original. So I only did one example, but I gave you some price changes for a stamp. So back in 1970, it was 6 cents. Current day, I need to update these notes because I know it's more than 44 cents. It might be over a quarter or 50 cents now. But anyways, I need to update these. So, but all you do is subtract and divide by the original, which is what I've shown you here. But remember, 6.3, that we need to change that into a percentage. So move your decimal over 2 places and it's 633% increase. And that's where you can really see how you have to be careful when you read an article and they say the cases or whatever is going on was increased 120%. But if you're talking about one person and it increased, now there's 2 or 3 people, Yeah, you have to be careful how they can really manipulate those percents to make it seem like a big change, but going from 6 cents to 44 cents, that's not, I mean, that's not going to break the bank. So, yeah, you have to be a little bit careful. And then just be careful if it's something, I didn't show you any that decrease, but if it does decrease, you need to say decreases or put a negative in front of that percentage. Okay, so, all right, email me if you have any questions and please do your homework.